Okay, welcome. So I'm going to work through our exam 2 practice problems. You may have already looked at the handwritten solutions, but I'll talk my way through these and hopefully answer any extra questions that you have. Of course, if you still have questions, please let me know before you take the actual exam. So we start the exam by just running through some derivatives, basically practicing our derivative rules. And so I'm just going to, on the side here, start working these problems. For number 1, we're doing the derivative of negative 342, which is a constant. So we know that that derivative f prime of x equals 0. And that's all you need to do for that one. Don't overthink it. Make sure you do put f prime of x equals along with whatever your answer happens to be, in this case 0. And in fact, as you're preparing to take the exam, if you can follow my example in terms of how I write my solutions, you'll have a better shot at getting the maximum number of points on each of these problems. For question 2, we're simply going to find the derivative of x to the 11th. We're going to use our power rule. So my derivative f prime of x is going to be 11, right? We bring that exponent down, x, and then we subtract 1, and we'll make that to the 10th. So f prime of x equals 11, x to the 10th. And that's our solution for number 2. Let's keep the ball rolling here. We have another power rule, but this time the exponent is a decimal number less than 1. We're not going to panic on this. You can still do the power rule on this problem. You just have to be careful about how you subtract 1. So that exponent 0.3 still comes down. And then my power on x now is 0.3 minus 1. If you're not sure about that calculation, please use your calculator. But I can do it in my head, and that ends up being negative 0.7. Let's just make sure I didn't make a mistake since I bragged about how I could do it in my head. Yes, that looks good. Okay, so we're all set there. Of course, I have my solutions sitting right next to me. I guess I could look at those as well. Okay, so that's 1 through 3. For number 4, things are going to get a little more complicated. So I'm going to move over here underneath and give myself a little more space. Oops, I do need a regular pen for this one. For number 4, we have a radical here. And notice my hint says change, my hint has a typo in it. It should say change the radical to exponent first. So what I'm going to do is rewrite the function. So this is not the answer. This is the original function in a different form. I'm going to rewrite it with a fraction exponent. That radical sign, that square root of x, can also be written as x to the 1/2. Now, because that radical is on the bottom of the fraction, that's actually a negative 1/2 in terms of the exponent. So it's 9 over the square root of x, or it can also be written as 9x to the negative 1/2. Now, when I want to go ahead and find my derivative, I can run through the power rule along with the constant multiple rule. So I'm going to bring that negative 1/2 down and multiply it by the 9, and that ends up being negative 9 over 2. You could also put negative 4.5 if you want, but all I do is I multiply the 9 by the 1 and just write the fraction. Here's where I need to be extra careful. The power on x is going to be negative 1/2 minus 1. When you do that math, you get negative 3 over 2. And in terms of our exam, I'm going to recommend that you just leave it like this. There is a way we can rewrite this back into radical form, and I suppose I could show you that if you want to see it. It's going to look something like this. Negative 9 over 2 times, what is this? The square root of x cubed. So if you wanted to rewrite it, you could. That's what it would end up looking like. But I am perfectly fine with you stopping here. For the purposes of our course, just being able to run through that power rule is all we need. We've got a couple more polynomials here that we'll run through, and then this first video will be done. We're on number 5 here. Ooh, I'm actually going to need a little more space, but let's put number 5 right here. all I'm going to do is run through my derivatives of each of these terms. So I can just use my rules to knock this thing out. It shouldn't be too bad. So f prime of x equals, I might run out of space here, so I'm going to slide this over just a little. I have to bring that 7/3 down, that's the exponent, and multiply it by 6. When that happens, I end up getting 14. You can double check my math on that, but 7/3 times 6 is 14, basically because 42 divided by 3 is 14. And then the exponent, I have to do 7/3 minus 1. So I'm going to subtract 3/3. So that's going to be raised to the 4/3 exponent. On the next term, I'm bringing the 3/2 down, 3/2, multiplying that by 2/3, that's 1. So I'm not going to write a coefficient in front of that. I'm just going to put the power of x, because it's just 1x, raised to 3/2 minus 1 is 1/2. So that's basically the square root of x. The next term has a minus sign, and I'm just going to bring the 6 down, multiply by the 4, so that's 24x to the 5th. And then the derivative of -9 is 0. So I'm not going to write that on there. So we're done with this question. Number 5 is done. That wasn't too bad. You just do each term individually. We're allowed to do that because of our sum and difference rules. And we get this expression here. Now, number 6 has another hint. And I think this one's not written with a typo, so that's good. But it says, the hint says, oops, I don't want to erase here. The hint says, for number 6, change to a polynomial first. So what I'm going to do, oh man, I'm just having trouble resting on this thing right now. Sorry about that. For number 6, instead of writing this function with these fractions the way they're written there, I'm going to use my rules for exponents to rewrite these with negative exponents. So it looks more like a polynomial. So 1/x to the 4th is the same as x to the -4. And 6/x squared is the same as 6x to the -2. And 10/x is the same as 10x to the -1. So this is not the answer. All I've done is rewritten f of x. Now I'm ready to use my derivative rules to find f prime of x, the derivative here. Okay, so my power rule says I can bring that -4 down and then subtract 1. So -4 minus 1 is -5. Be very careful with how you subtract these negatives. It's a little tricky. The next one, I'm bringing -2 down, multiplied by the 6, so that's a -12 or -12. And then -1 would be x to the -3. And then -1 times -10, that's a +10. And this would be x to the -2 when you subtract 1. I am perfectly fine with you leaving that answer like that. However, if you want to put it back in the original fraction form, here's what it would look like. So you could also write this as, this would be -4 over x to the 5th, right? That x to the -5 ends up being in the denominator. The next one would be -12 over x cubed, because the x cubed goes to the denominator. That -3 exponent, it only affects the x. It does not affect the 12. So the 12 stays in the numerator. And this last one's going to be 10/x squared. So if you want to, you can rewrite it as fractions, but I'm perfectly fine with you leaving it written with the negative exponents. So these are the first 5 solutions. And hopefully hearing me talk you through it helped if you were having issues or if you had any questions. And of course, before you take the exam, please voice your questions and concerns so that you'll be prepared when you get there. That's it for this one. I'm going to break these up into shorter videos so you don't have to wade through one whole big video just to find one question. But this includes 1 through 6, and then I'll pick up with number 7 in the next video.